Hello friends, welcome to Embedded Sparks. In this video, we will be seeing about 4 different examples for Arduino programming. Here, I will be using Walkwe for online simulation. Without any physical Arduino, you can even code it and see the output. So without any further delay, let's get started. Firstly, let's see about fade example. This example shows how to fade an LED that is being connected on pin number 9 using analog write function. This is one of the most important functions in the Arduino programming. So this function uses PWM, which means pulse width modulation. We will be seeing about this in detail in the upcoming videos. So if you want to change the pin you are using, you can just use any other PWM pin that is being available on the Arduino board. It will be identified using the tilde symbol. In the Arduino board, if you see, you can just see tilde symbols for certain pins which can be used for this particular function of PWM. So next, let's get into the code. So in the void setup function, we will be initializing the pin that is LED pin as output pin. So here we are initializing it like LED to 9th pin, and then we are setting brightness to be 0 and fade amount is being given like 5 initially. Then in the loop function, we will be running it infinite times, that is it runs over and over again. So here we are giving the analog write function where we are passing the LED pin number 9 as the argument and the brightness. Initially it is 0. Then the brightness is being incremented by the fade amount 5. So initially it's 0. Now it becomes 0 plus 5, which is 5. Then we have a control structure, which is the if statement. If this particular condition is true, then the code inside it will be executed. Otherwise, it just skips this particular structure. So here the condition is brightness less than or equal to 0, or this particular thing is logical, or brightness greater than or equal to 255. Then you have to make it as fade amount is equal to minus of fade amount, and we are giving it a delay. So how the flow works is that firstly 0 plus 5 is equal to 5. Then this particular if statement will not work because the condition is false, because we have the brightness to be 5, which is greater than or equal to 0. So this loop, this particular structure will not work, and then the delay is given. So it waits for 30 milliseconds to see the dimming effect actually, and then again it just calls the analog write function with the LED, and now the brightness will be 5. Then the 5 plus again fade amount 5, now the brightness will become 10, and this repeats again and again till 255. Once the brightness has reached 255, then on incrementing it by 5, we get it as 260. Now this if condition is true, so now the fade amount will become minus fade amount, that is it now become minus 5. Again after the delay it goes to the loop. Now LED brightness is 260, so now brightness 260 minus 5, so now the fade amount has become minus 5. So 260 minus 5, 255, and again it just goes on dimming it. So basically firstly from 0 to 255 it increases, and again from 255 to 0 it decreases, and this particular loop goes on. Now let us see the output in the Walkwe simulator. Here I have just connected the cathode of the LED to the ground and anode to the pin number 9 along with a resistor, current limiting resistor of 220 ohm. Let us run this and see. So you can see the dimming effect over here, that it increases and then it decreases. The dimming effect, the brightness of the LED is being faded, and you can see the output clearly. So this is about the first simulation example. Secondly, let's move on to another example, that is button. This is quite simple, you can easily understand it. So here I am just giving constant, that is this particular variable doesn't change over the code, so we are declaring it as constant. Button pin is pin number 2 and LED is pin number 13, which is actually built-in LED in the Arduino Uno board. Then initializing button state as 0. In the setup function I am setting LED pin to be output and the button pin to be input, and now in the loop function we are reading the button pin's status, like we are digitally reading it, either it is on or off, 1 or 0. So based on the button state, if it is high, that is if it is 1 then it is high, we are comparing it. If it is, then you will be getting it as the LED pin to be high, that is the LED will be on using the digital write function. Else if the button is not pressed, then the LED remains low. Here instead of using input, you can use input pull up, which just have the button to be in a high state in the initial. So if you just doesn't give any pull up or pull down, then the button will be in floating state, which is kind of uncertain. So it is a better practice to use pull up to actually have a better thing. Here I am just using the external resistor for pull up purpose. You can even put it as input underscore pull up, which is actually an inbuilt keyword is there for Arduino, you can use this. So at that time you don't need this particular resistor. So now I will just connect it the external pull up resistor. The concept of pull up and pull down I will be giving another separate video for that just in the upcoming videos. So now let us look into the walkway. Now the code is same. So now the button is being connected to pin number 2. Here I have used pull up resistor which is being connected to pin number 2 and the 5 volt. The concept of this will be dealt in the upcoming video. So then the another terminal of the button is being connected to ground. Then here the LED is 13, pin number 13, which is built-in LED. If you want some other LED pin to be used, then you can connect it externally as well. Now let me run this simulation. Before running it, let me make it clear that pull-up resistor, what it will do is that the initial state will be in on. That is, this particular LED built-in will be on when the button is not pressed. And if I press the button, then the LED will be turned off. Here in this code, if you see, the digital read of button pin, initially it will be high. So if the button is high, then the LED pin will be on. So in the normal state, without the button being pressed, then it will be in on state. If I press the button, then it will become low, which means the LED pin will be turned off. So let me run it and show you. Initially it is in on state. If I press the button, then it will be in off state. So I'm pressing it, so it is in off, and releasing it, so it is in on state. So this is about the second example. Then let us move on to the third example, which is analog read serial. So reading an analog input on the pin number 0. Here A0 represents that the analog pin number 0, and we will be printing it in the serial monitor. Here also we have the serial monitor over here. If you press this, you can see the serial monitor, but since I'm not going to do it on the physical Arduino, we'll be using Walkway software for that. I mean simulator online for that, Walkway simulator online for that. So here then we will see the setup function. Here initializing serial communication. For the communication we are using 9600 as baud rate bits per second, the rate at which the transfer of data occurs. And in the loop function I am using analog read, which reads the value that is being there in the analog pin number A0. That is, sensor value is being just stored in the particular variable, and we are printing it in the serial monitor and with a delay for stability. Let's look into the simulation. So here in this particular potentiometer, I'll be using it for changing the values analog. So yeah, so in Walkway, let us see. So the code is the same. So the analog read of A0. So I'm connecting a potentiometer to the pin number A0. So this VCC is being connected to 3.3 or 5 volt, either of the thing you can connect it with, and the ground to ground, and another pin, this is signal pin, to the pin number A0. So I'll be changing the spot potentiometer, and we can see the corresponding values. Here the ADC will be there inbuilt, like Arduino has inbuilt ADC with a resolution of 10 bits. So 2 power 10, it is 1024 minus 1, 2 power n minus 1. So n is the bit, so 10 bit resolution, so it can vary up to 1023. So 0 to 1023. Let me run this simulation and show you. So now it's in the minimum value, which is 0. I'm going to vary this potentiometer, and you can see that the value is being read and it is being printed on the serial monitor. The maximum it can go is up to 1023. Okay, that's it. So let us move on to the final example for this particular video. It is read analog voltage, similar to what we see in the previous example, similarly here. But the thing is, you can just control the voltage value. Like, let me tell you, same thing, serial dot begin 9600, and we are reading it from A0. And here I'm just converting the analog reading from 0 to 1023 to voltage of 0 to 5 volt. Here I am using float voltage as the variable name. I am giving the sensor value, which can be from 0 to 1023 into 5, which is the voltage value, divided by the resolution of the ADC. So here it is 10 bit resolution, so maximum value 1023, and I am printing it in the serial monitor. Let us see in the Walkway. So here instead of using the normal potentiometer, I have used the slide potentiometer to show you the difference, the same functionality. So here I am connecting it to VCC to 5 volt and ground to ground over here, and here the signal is being connected to A0. Same. Let me just run this. So initially 0. Now the values will be from 0 to 5 volt. That's the difference. So here you can see it is in voltage. The previous one we saw it as the digital value itself. So the maximum voltage will be 5 volt. That's it. So thank you for watching.